If you've spent the last few evenings scrolling through endless rows of CNC routers, watching video after video, and still feel that knot in your stomach wondering if the machine you pick will actually let you bring those designs to life, you're not alone. That hesitation wondering whether you're getting enough power for the wood you love to carve, enough precision for the PCB traces you need to mill, or simply a machine that won't drown your garage in noise can turn a promising hobby into a costly lesson. Link is in the description if you want to check the product details on Amazon. In the next few minutes I'm going to walk through the Tenhai 3040 800W CNC router, point out exactly where it shines, where it trips up, and help you decide if it's the right fit for your workshop or if you should keep looking. First off, let's talk about the space it occupies. The 3040 in the name tells you the travel envelope, roughly 300 mm in the z-axis and 400 mm in the axis. That's about the size of a standard sheet of paper laid flat, give or take a few centimeters. For hobbyists who work on small signage, decorative keychains, or desktop-sized prototypes, that envelope is actually generous. I've seen makers carve a full-size wooden coaster in a single pass, and the extra 100 mm in Y gives you room for a couple of parts stacked side by side without rejogging. If your goal is to cut full-size plywood panels for furniture, you'll quickly discover the limitation: you'll have to split the job into sections, which adds time and alignment work. Now, the power. The 800W spindle is a middle ground offering. It's strong enough to handle pine, birch, and acrylic at decent feed rates, and I've watched users get clean cuts on 3mm PCB material without burning the copper. When you move up to denser hardwoods like maple, you'll need to dial back the feed and perhaps make multiple shallow passes to avoid chatter. The water cooling system built into the spindle is a real plus here. It keeps the motor temperature down during longer cuts, meaning you can run for 20 minutes straight without the thermal shutoff that plagues some air-cooled spindles. That said, you do need a small reservoir and a pump, which adds a bit of plumbing to your bench. If you're okay with setting up a loop of tubing, the cooling pays off in consistent cut quality. If you want a pure plug-and-play experience, the extra components might feel like an unnecessary hassle. One of the headline features is the upgraded fourth axis. In plain English, that's a rotary spindle that lets you turn the workpiece and mill on its side, opening up 3D engraving possibilities. Think of a small wooden vase you want to add a spiral groove around, or a cylindrical acrylic tube that needs a logo wrapped all the way around. The fourth axis on the Tenhai is driven by a stepper motor and integrates through the same control board, which is convenient. You don't need a separate controller. In practice, setting up the rotary attachment takes a bit of patience. You have to zero the rotation, align the tool path, and make sure the workpiece is firmly clamped. Once you get past that learning curve, the added dimension is worth it for anyone who wants to move beyond flat engraving. If you're strictly cutting flat panels, you may never touch the fourth axis, making it a feature you'll pay for but not use. The USB port is another practical touch. Unlike many entry-level routers that rely on a dedicated SD card or a network connection, this machine lets you plug a flash drive straight into the controller and run code files without needing a laptop on the bench. That can be a game changer if you're working in a cramped garage where a laptop would just get in the way. The downside is that the firmware on the controller is fairly basic. It reads the code but doesn't offer advanced simulation or visual feedback. You'll still want to preview your toolpaths on a computer before sending them over, so the USB port is more about convenience than replacing your normal workflow. Precision is driven by the ball screw drive on both axes. Ball screws reduce backlash dramatically compared to a typical trapezoidal lead screw, which translates to tighter tolerances on small parts. For instance, users have reported achieving sub 0.1 mm positioning repeatability when engraving fine lettering on acrylic. That level of control is essential if you're making interlocking wooden puzzles or fitting components for a DIY robot. However, ball screws also demand regular lubrication and can be louder than a belt-driven system, especially when you're moving at higher speeds. If noise is a concern for a shared space, you might need to invest in some acoustic padding or consider running the machine during off hours. Let's talk about the software side. The controller runs a version of GRBL, which means you can use any standard CAM package that outputs standard code. There's no proprietary software lock-in, which is a relief for people who prefer open-source tools like Fusion 360 or Easel. The learning curve is the same,